start recording here. Okay, cool. So last time we met, we went ahead and went over basically just the setup about the competition, but we also went over open source intelligence. So we're basically done with that topic unless there's some other questions that you guys had in between the last meeting and now, which I'm going to assume there aren't any. Okay, cool. Let me know if you can't see my screen, by the way, Rohil. But if you can, good.
Wait.
Okay, sounds good.
It's loading. Yeah, I can see.
Okay, sounds good. Cool. So, okay. So today we're going to get into the second topic that we were supposed to cover on Saturday, but unfortunately I wasn't available. But that topic is going to be password cracking. So password cracking is a little bit more technical than open source intelligence, right? Open source intelligence, a lot of it can be browser based, right? You can just look up stuff and it's there. Whereas with password cracking, you oftentimes need more specific tools. Okay, so let's start off with the fundamentals. So basically, obviously passwords are meant to be secret, right? Usually passwords are what are called hashed, okay? If you've never heard of the term hash, or hashing, or hashed, whatever. Basically, hashing is a function, okay? It's a one-way function to obfuscate information. So very important, it's one way, which means that it cannot be reversed. I put an example here. You can think of like a door with no handle on one side. So once you kind of go through that door, you can't go back through the same door, okay? So hashing basically takes whatever data and obfuscates. Obfuscates just means to hide it. Okay, so it hides the detail. So let's say my password is like ABC123. If I put it into a hashing function, which I could actually do really quickly, let me pull it up here on the second screen. Okay, so if I go to, let's say, an MD5 hash, MD5 hash is very insecure. You don't want to use it. But anyway, so let's say my password is ABC123. I can then use the generate button here, and it gives me this MD5 hash. This MD5 hash is a representation of this information, okay? So I can't, well, okay, with MD5, you could more easily figure out what the original password is using this string, but generally speaking with hash functions, you're only able to do it one way. So if I have this hash, I cannot then reverse it to the password. Ideally speaking, right? You could still brute force it and stuff like that. But the idea is there isn't a function that I can just plug into and get my original output from, okay? So that's the idea of hashing, okay? So usually passwords are hashed, right? Whenever they're stored. Okay, another type of obfuscation is what's called encryption. Okay, so if you've never heard of encryption, encryption is basically kind of like a hash, except it's two-way, okay? So in a hash, right, I can have a piece of data and I can plug it in and then I can't reverse that data back to the original. With encryption, I can encrypt that information, right? I can hide the original information as some string that I can later decrypt back into the same function. So encryption is kind of like hashing, except it's two-way. Just in the same way how hashing is kind of like encryption, except it's one-way, if that makes sense. So just imagine that hash example that I just brought up. If I can pull it up really quickly. There it is. Let me see here. So if I just do, let me see, just RSA encryption online. Let me see. Okay, so okay, I would need a public key in this case, but basically the idea is, right, you just enter the information that you want to encrypt, like let's say ABC123. I would need a special kind of like key to be able to do it. Actually, let me just encrypt one. RSA key pair generator. Let's just do one really quickly. So let's generate. Okay, here's my private key. The private key you're supposed to keep secret. Obviously, it's private. The public key is what you give to the other person. Okay, so anyways, so here I go. I can encrypt my data, right? So here it is encrypted, and then another person on the other end could then take this encrypted data and then decrypt it and get back the original information. Okay, so hopefully that illustrates a good example of the difference between hashing and encryption. Okay, or yeah, hashing and encryption. Like I said, the encryption process requires using a private and public key. I'm not going to get into the details of exactly what goes on right now behind the scenes. There's plenty of classes on campus that go over that. But you could look it up online, like how does public and private key encryption work. Feel free to look it up online. But basically, you just get some information. You get a key. You use that key to encrypt information. Then you get that encrypted information. You can then take that encrypted information and decrypt it using the other half of the key. Okay? Cool. Let me hide this. Okay, so that's encryption. Now, some other important phrases you're going to need to know are salt and pepper. So yes, those are the names of seasoning, but in this case, we're not trying to season our passwords. So salt is basically the idea of adding random data to a password to prevent what's called a rainbow table attack. Okay, so let me pull up the hashing one more time here. Okay, so basically, let's start with a rainbow table. Okay, so let's say I had a list of passwords like A, whatever, so on and so forth until like like AB or something, and then so on and so forth until I get like passwords like password 1234, whatever. This is just a string of like what's called a dictionary. It's a bunch of different like common passwords. There's like password lists that you can download online with this kind of information. Okay, so anyway, let's say I were to take A, for example, and generate a hash. Okay, so it gives me this hash. Let's look at the last four, 2661. Okay, so let's say I generate another one, and then I go back and generate A again. Notice how it gives me the same exact hash. Okay, it's not random. So 2661. So that means that anytime there's an A and I encrypt it using MD5, or sorry, hash it using MD5, it's going to give the same output. So what I can do is I can go and create a list of the 1,000 most common passwords, and then if I hash them, then I can get a list of hashes, like how they're stored. Okay, then let's say I were to hack a database, okay, and in the database, all the passwords are hashed. But I have 1,000 of the most common password hashes. So if I just run a quick comparison over, the whole database, I can actually figure out what the password is from the hash. Okay. So yeah, so this principle that an input will always give you the same output is the principle behind using a salt. Okay. So again, a salt is a random piece of information added to a password. Okay. So let's say a password in this case is ABC123, like my last example. A good salt could be something like, I don't know, let's just say $123, whatever. Okay, and this is always random. So in another password, I'll have like exclamation point, AB exclamation point, or something like that. And basically, what this allows us to do is every time we generate a new hash, it gives us a different one each time. And it basically makes rainbow tables almost ineffective. Almost. Okay, so that's the principle of a salt. Random data added per password to prevent rainbow table attacks. Okay, so random per password data, right? It changes on every password. Now, on the other hand, a pepper is similar. Okay, so a pepper is a secret value, okay, that we add to the end of each password in case of a database leak. Okay, so let's bring up that hash again. So in this case, let's just say ABC123 is my password, and I'll add exclamation point pepper at the end of my password. If I then have another password like 321CBA, I can add that same pepper. Okay, this means even though my password is ABC123, right, the hash for it isn't what would be returned from just inputting ABC123. Hopefully that makes sense. So obviously peppers are a little bit less secure than salts, in the sense that once you know the secret for all the passwords, right? Whereas with a salt, it's different each time, okay? So let's say for ABC123, I have salt 1, and then for 321CBA, I have salt 2. Oops, salt 2. Okay? So salts are different each password. Salts are the same in each password. Peppers are salts are different for each password. Peppers are the same for each password. There we go. Okay. So, why would you want to use one over the other? Obviously, peppers are less secure, but they're much easier to implement, right? You just add some piece of data to the end of a password and boom. But because of its insecurity, right, a salt is what you would generally want to do. And a lot of password hashing libraries, whenever you're writing code, they also have the ability to salt automatically. So you technically don't even need to do anything with salting. Salting is just a little bit more complicated to implement. So that's why somebody might use a pepper instead of a salt. Okay, last thing is a collision. So a collision is what happens when two or more passwords give the same hash. Now, I wish I had an example pulled up, but basically the principle is, imagine if I had two passwords, like let's say ABC123, and another completely different password like password 12, or let's just do password 987. Completely different. The idea with collisions is if the hashing algorithm isn't good enough, what will happen is two pieces of completely different data will give me the same exact hash. Okay, so the algorithm behind the hash will what is called collide. Now, collisions happen in any kind of hashing algorithm. It's just the better ones have less collisions, so it's less likely to happen. Okay, so a collision is just basically when two or more passwords result in the same hash. Okay, now why is a collision important? For example, let's say somebody's password is something super strong, like $, this is a strong password, let's just say. Okay, let's just say somebody's password is like that. Okay, now we can generate the hash for it, and if I'm using a weak hashing algorithm, what could happen is an attacker could just try brute forcing, and it could just so happen that this password has the same hash as, let's say, A. Okay, so if an attacker just enters A right into your account, the hashes could match up even though the passwords are completely different, right? So in this case, a collision is very, very undesirable, right? That means that somebody could gain access to your account with a completely different password. In this case, one that's even easier than the original, right? So even though your password is really strong, if the hashing algorithm that is used is weak, there's kind of no point, almost. Okay, so those are the main fundamental keywords. Any question on those keywords at all? Okay, cool. Let's move on to some hashed algorithms. So the one I showcased is MD5. MD5 is very fast, but it's insecure due to those aforementioned collisions. Okay, so that means that more than one value can multiple different values can result in the same hash, and those collisions basically end up breaking the hash algorithms. Nowadays, it's mainly used for what are called checksums. Checksums are, okay, so let's say I download a file, right? I can then hash the contents of that entire file, and it'll give me some value. Then I can go on the website and I can check, okay, what's the intended hash and what is the hash that I got? If both of those hashes match up, then that means one, my download was successful and my file didn't get what's it called? It didn't get what's the word I'm looking for? It didn't get compromised, right? So an attacker didn't replace the file with some malware, but also it means that my download was successful, right? It didn't get corrupted. Okay, so that's mainly what it's used for. But again, even now, MD5 is just completely unused just because of those collisions. Those collisions just means that more than one file can result in the same checksum. People have actually reverse engineered MD5, and so they can make a file result in the same hash. So it's actually super cool. You could actually look it up. But for the purposes of what we're learning, MD5 is completely irrelevant. Okay, next is SHA-1. Again, it's much like MD5, but for that same reason, it's still insecure. So it's not used due to those collisions. Still very fast, though. Okay, next is SHA-256. So SHA-256 is a secure iteration of SHA-1. Now, SHA-256, sorry, I should define what SHA is. SHA is secure hashing algorithm, and then the number after it, 256, is how many bits are used in the algorithm. MD5, I don't remember what it stands for, but it's something digest. Not important, but anyways. So yeah, so SHA-256 is just a more secure version of SHA-1. Okay, now onto more modern tools. We have algorithms like bcrypt. Okay, so bcrypt is actually a production-capable hashing algorithm. What that means is if you use bcrypt in your app or your website, it'll be perfectly secure as possible. Okay, so even though more secure or better algorithms exist, like we're going to touch on in a second, bcrypt is just fine for modern encryption standards. Obviously, as we move into the future with stronger computers, bcrypt is probably going to become a little bit insecure, but it's still highly recommended to use. Another one is PBKDF2. I don't remember at all what that stands for, so please don't ask if that's one of your questions. I'll have no idea. But it's a very strong algorithm. It's very tested. So people have tested it, made sure that it's very secure. And it has what are called customizable parameters. So you can customize the amount of iterations, how long you want the hash to be, and so much more just to increase the security. So PBKDF2 is a very strong algorithm that's used in some programs to hash passwords. Now, the other one, the last one, is Argon 2. So Argon 2 is it's relatively brand new. I believe it's only been out for like 5-ish years. Feel free to look it up and correct me. But again, it's another very, very strong algorithm with, again, customizable parameters. Due to its security, it's actually preferred in the industry. So a lot of places are trying to move away from older hashing algorithms like bcrypt and move towards Argon 2. Okay, so Argon 2 is probably the most is the strongest, but it hasn't been fully tested yet to determine if it's safe against collisions and stuff like that. But as far as we know now, it's the most secure option that we have. Okay, cool. Now, all of these different hashing algorithms have their own output. And the cool thing, actually, there exist tools that actually allow you to identify the kind of hash that is used. So let's see, hash identifier. Let's see if we can use it really quickly. So I'm going to take this hash that I have here, and let's put it in here. And let's see if it can identify it. Could not identify it. Let me try one more time. Oops, that's because I put in a completely wrong one. One more time. There we go. Identifying hash. And it looks like, as you can see, possible algorithms MD5. So even though this information looks completely useless to us, right? There's nothing we can do from this. There are still patterns in this hash that allow us to identify what algorithm may have been used to hash it. Okay, so very powerful tool. Now, why would you want to use these kind of tools? So let's say, again, you were an attacker and you had access to a database, right? And that database is full of hashed passwords, right? The database isn't going to say what algorithm the password was hashed with, okay? All it's going to say is that it was hashed, right? So you could use tools like a hash identifier to figure out what possible algorithms could have been used to hash to get a certain hash. Now, for example, we have SHA-1 and SHA-256, right? A lot of these algorithms tend to have the same patterns. So sometimes these hash identifiers aren't completely sure what the possible algorithm is, but you could at least use these tools to narrow down the kind of hash that was used to hash a piece of information. For the purpose of our competition, right? Let's say there was a question where you were given a hashed piece of information and it asks you what algorithm was this most likely hashed with. You could use a tool like this to figure out, okay, it's MD5. Okay, cool. Okay, so that is that. Now, let's move on to some techniques for actually cracking the passwords. Now, obviously, it all starts with recon, okay? So we're trying to figure out as much information as possible, okay? So if we can find stuff like salts and peppers, right? In this case, right, because salts are random, what we mean by find salts is try to find out how the salts are generated, right? If you can figure out how they're generated, you can maybe reverse engineer them, okay? Same thing with peppers, right? If you find the secret value that's added to each password, it's going to make cracking the passwords 1,000,000 times easier. Okay. Likewise, if you can figure out the exact algorithm that was used to get the hash, boom, going to narrow down your cracking. And as well as parameters. So for algorithms that have customizable parameters, you need to know the exact parameters to be able to crack the password. Right? Well, you don't need it to crack it, but it makes it significantly easier, right? It cuts it down by a lot. Okay, so obviously, when you're trying to figure out passwords, the ones that you're going to try to target are unsalted fast hashes. So for example, if my database in my app stored passwords as MD5 hashes, those are unsalted, first of all, and second of all, they're super fast. So an attacker could basically reverse my password database in a matter of maybe hours, depending on the size of the database, right? So attackers are going to prioritize the easiest solution, right? So obviously it makes sense, right? Why would they go for something that's harder when they can do the same thing if it's easier? Cool. Okay. Now moving on to actual tactics. Okay, so the first one is what's called a dictionary attack. So a dictionary, right, like the dictionary book is just a book of a bunch of words, right? Likewise, a dictionary in terms of password cracking is just a giant list of the most common passwords. Okay, so we could actually probably look that up really quickly here. Let me see. Most common passwords. Let's just look it up. Okay, Wikipedia. So boom. So Wikipedia says 1, 2, 3, 4, 5, 6, 7, 8, 9, blah, blah, blah. These are the, looks like, top 20 most common passwords. So if I had a database of, let's say, the 1,000 most common passwords, I can then compare the hashes of those 1,000 passwords against a database sample, right? So I could do this manually, for example. So let me pull up that list one more time. So let's say this QWERTY 1, 2, 3. Okay, I can then take this, hash it, And then I can see, okay, does the password for user Eunice, for example, does his password match this hash? If so, then this is his password. And I can go down the line one by one for each database entry. Okay, so that's a dictionary attack. Basically, just a giant list of the most common passwords. Usually, it's not just like the 1,000 most. It's usually like 1,000,000 of the most common passwords. So yeah, obviously, the dictionary attack is going to be the fastest, and it's the most effective against weak and non-unique passwords. Non-unique means if your password is on one of those lists, okay? So, for example, if your password is password123, that's not a unique password, okay? It's very common, in fact. Is it possible to have a definitely unique password? No. It's very likely that somebody else on the earth is going to have your password as well, but it's important to have as unique of a password as possible, okay, to basically guard against these attacks. Okay, so that's a dictionary attack. Now, as for rule-based attacks add on to a dictionary attack. Okay, so let's say I had a dictionary, okay, but I had some rules that I wanted to define. So, for example, I wanted to add numbers to a password, or I wanted to do what's called leet subbing. So it's like where you replace O with 0 or E's with 3's, stuff like that. So it's what's called leet code. If you've never looked it up, not the website leet code, but the thing here. Let me just pull it up just so I don't look weird. Leet code. Oh, I think in this case it's a programming language. Okay, well I don't mean it in a programming, but it basically kind of looks like this. So leet speak is uber cool and easy when you think it through. So you're replacing letters with numbers. Sometimes you're replacing letters with symbols like the $ here, or you'll replace a with at, for example. So stuff like that. So I can take a dictionary list and try to see if maybe the user was using leet subbing. You could also try to do all uppercase, all lowercase, capitalize some letters, stuff like that. So it's basically taking a dictionary attack and adding some rules onto it. Okay, so for that reason, because we're adding some rules, it's going to be a little bit slower than a regular dictionary attack, right? Because we need to calculate all those rules. But it is effective against non-unique passwords with substituted characters, okay? So for example, let's say I had that password 1 example. Oops. Let me pull up the thing. So here's this password. So let's say I just replace this with leet. So for example, p at 55wz0rd. Okay. Generally speaking, that would be good against a dictionary attack, but that would be completely ineffective against a rule-based attack. So even though the password is quote unquote unique, because it's unlikely to be in a dictionary list, it's not actually unique because all you're doing is substituting characters for a similar representation, if that makes sense. Okay, so that's rule-based attacks. Now another one is a mask attack. Okay, so a mask attack is when you have partial knowledge of what a password is supposed to be. Okay, so for example, I'm sure we've seen on many websites, right? There are password requirements, right? Your password needs to have it needs to be between 4 and 16 characters. It needs to have at least one number, but at most 3, right? Stuff like that. When we know what the password is supposed to look like, we can actually create a mask like this. So this is an example. This is an example of a mask of passwords that start with a capital letter, followed by 4 lowercase letters, followed by 2 numbers. Okay? So a mask attack is basically a targeted brute force. We'll get into brute force in a bit. But basically, it allows you to narrow down your possible permutations of passwords. Okay? So kind of to describe mask attacks, we're going to need to get into brute force. So let's jump from mask over to brute force really quickly. And brute force is actually very simple. Brute force is where you try every single possible combination, right? A, so on and so forth until you get to, let's say, A, B, AAB, so on and so forth, okay? Brute force is very, 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 very expensive, right? Because there are any possible combination of passwords, right? If a password is just letters, at the very least, let's say the password could be anywhere between 1 and 26 characters. That means that you have 26 to the 26th power of possible combination, which is insane, right? So brute forces are really only viable. They should only be used for short passwords, right? If the password could be like, let's say a 4-digit number, right? A PIN, right? A PIN is a great use case for brute force because it doesn't take too long to get through all the possible combinations. Okay, so jumping back to mask attacks. So a mask attack is a targeted brute force, right? So we're still trying a bunch of different combinations, but by defining a set of rules of what our combinations should look like, we narrow down the possibilities. Okay, so that's mask attack and brute force. Now moving on, we have hybrid attacks. So hybrid attacks allow us to apply masks onto word lists. Okay, so imagine I had a dictionary of a million of the most common passwords, right? I can try all those million passwords, but if none of them work, I can then employ a mask attack to try to change up the passwords. Now, in that sense, it's actually very similar to a rule-based attack, right? We have a bunch of words and we're adding words, and we're adding rules onto them, right? Adding numbers, substituting characters, stuff like that. The difference between a hybrid attack and a rule-based attack is that it's more definable, right? So here I can only add numbers, right? Let's say I can only add numbers to the end of a password, but let's say the number was somewhere in the middle of my password, right? I can use a mask to define that a password should have a number in the middle of it. Okay, so that's kind of the difference between hybrid and rule, though they are generally kind of interchangeable, generally speaking. Okay, cool. Now, we touched on this already slightly, but the last kind of attack vector that we have is a rainbow table. Okay, so a rainbow table is a pre-computed list of hashes. Okay, so let's say I had that same database of the million most common passwords. I can then calculate the million most common hashes. Okay, and if I have a list of the most common hashes, then I can compare the hashes that I got from, let's say, a database leak to this rainbow table. Now, the problem is it's largely become obsolete. So rainbow tables were only popular like years ago. They're not a thing anymore. Firstly, because of salts. So salting your password has basically made rainbow tables ineffective, but also because of how slow secure hashes are. So with encryption and hashing algorithms, their efficacy, right, how good of an algorithm they are, is kind of directly proportional to how slow they are. So if it takes a lot of computing power to calculate a hash, then it is deemed more secure because it takes more work for the attacker to try to figure out the hash as well. Okay. The other reason it's obsolete is because these pre-computed lists are gigabytes. So we can actually pull up a example of rainbow tables. Let me see. Rainbow tables. I should say download. Okay, so free rainbow tables. So here's a resource where you can go and download different rainbow tables. So for example, here we have a rainbow table of passwords that are all lowercase from 1 to 10 characters. Okay, so passwords that are 1 to 10 characters long, all using lowercase characters. Okay, so and also you could see we have multiple different hashing algorithms. So for example, SHA-1, this rainbow table is 179 gigabytes long. For MD5, it's also 179 gigabytes long. Okay, so you need to download both of these tables, right? Unless you know the hashing algorithm, right? Which we saw is a little bit easier to determine, right? You need to download this and run it, right? So let's say you don't have 179 gigabytes of space, which, before, right, not too long ago, was actually kind of a lot of storage, right? When we had like 512 gigabyte storage drives or 256, right? When your drives were that big, right, 179 gigabytes just didn't make sense to download. Okay. Then if we look at another example, so if we have passwords that are all lowercase and also have numeric characters between 1 and 10 characters, that shoots up all the way up to 587 gigabytes. So just by adding the possibility that there could be numbers, we basically almost 4x'd the amount of data that we need. Okay. If we look at an even bigger example, like this one right here, mix alpha numeric 1 through 9. So that means that a password could be, any character in a password could either be uppercase or lowercase, and it could have numbers, okay? And the password length is anywhere between 1 through 9. As you can see here, okay, they can go anywhere from 500 to 1 terabyte of storage space, right? So we could see why these are not effective, right? These are obsolete. Nobody uses these anymore because of, one, due to the large file size, but also due to the fact that hashing algorithms have gotten stronger, and we now use salts. Okay, so rainbow tables are generally speaking ineffective. Okay, so I'm going to go ahead and post this link in the chat. So just like how we went over with in the OSINT, I'm going to go ahead and post a Google Doc that NCL made showcasing some password cracking tools. In this case, they are browser based. So let me pull this up on the other screen here. Okay. And so as you can see, we already looked up some examples. So a hash identifier, here we have some possible tools. You could do that. So tunnels up, hashcat. I believe hashcat is a local tool. I don't believe it's browser-based. But yeah, so these are an example. Another tool we could use is what's called a hash calculator. So, right, they basically allow you to generate hashes. So just like how I did with the MD5 hash generator, you could use this calculator to generate a hash. Okay. Now another one is a password hash cracker. These ones are generally not browser-based. You are able to find them, right? It outlines here to use the cloud version of OPH crack, right? You can use cloud solutions, but generally speaking, a lot of the times you are using local tools, right? So we're going to go over these tools in a bit. And there's also a link down here if you want to look at the author of this resource. Okay, so just some basic browser-based tools that you could use, not necessarily free. Okay, so let's get into some of the tools. So we already saw Hashcat in that list. Hashcat is a tool that not only identifies hashes, but it also allows you to crack those hashes as well. Not only hashes, passwords, basically. Password hacking, stuff like that. The cool thing with Hashcat is it allows you to run cracking on your GPU in parallel. So let's say you were using a single-threaded password cracking tool, right? You would need to wait after each possible crack to see if it failed or not. So I would need to try ABC, right? Check if ABC is the password. If it's not, move on to ABC1, so on and so forth. But with a parallel tool like this one that uses the GPU, or even one that multi-threads on the CPU, you can try multiple different hashes at the same time. Okay. Now, the efficacy is going to depend on how good your GPU is. If your GPU is really good, it's going to be able to crack it really fast. If not, it's going to be super slow. Now, another tool is John the Ripper. So John the Ripper is similar to Hashcat in the sense that it auto-recognizes hash formats, so it identifies hashes. But it's different in the sense that John the Ripper is a CPU tool. Okay, so it's not generally the ideal tool to go with because it uses the CPU and because it's a little bit slower for that reason. But it's good for, let's say, testing, right? So if you only need to run it something super simple. Okay, another great tool is HashID. So HashID, I believe, is a website it's a tool that you can download. And if you feed it a hash, it could determine the possible hashing algorithm of a hash. So we saw an example of that in the browser that we just ran. Okay, and the last tool here, even though rainbow tables are largely obsolete, I'm still going to include it. So OPH Crack is a password cracker, mainly used for rainbow tables, mainly used. Though you could use it for standard cracking as well. Okay, sounds good. So let's get into some exercises. Honestly, as you can see, password cracking isn't too complicated. Compared to OSINT, which had a bunch more stuff going on. The difficulty in password cracking comes from the technicality, right? How technical it is. Okay, so let's take a look at this first exercise, Rock U. Okay, so it says here, I'm going to obviously encourage you guys to follow along, and I'm going to go ahead and paste these in the chat. So boom, there we go. Okay, so it says, our analysts have attained password dumps, storing hacker passwords. After attaining a few plain text passwords, it appears that they overlap with the passwords from the RockU breach. Okay, so in this case, what this problem is saying is to basically try to figure out what the password is. Okay, so let's do this one together. Any idea where we can start? And again, I haven't done any of these exercises, so I'm doing these for the first time with you guys. Okay, so let's start. Where can we start? Any ideas at all?
Hash analyzer.
Hash analyzer? Sure, yes. What's another thing we can possibly do?
Just going into straight trying to decode it.
One more time?
Just trying to decode it right away.
Trying to decode it right away? Well, here's the thing. It's hashed, so we can't decode it, right? So with a hash, it's a one-way, right? We can't directly say this, we'll take this string, put it into some function, and we get some output, right? We need to do some kind of comparisons and collisions and stuff like that. So we can't. There are instances where you can decode, where you reverse engineer a hash algorithm, but generally speaking, encryption is something that you decode, whereas hashing isn't. It's a little bit complicated. So decoding, no, but yeah, we could definitely go and try to figure out which hash it's using. So can you guys tell me what hash this is possibly using? So go ahead and try to figure out the hashing algorithm that any one of these is using. I'm sure all of them are using the same one.
The first one said MD5 or MD4.
Okay, the first one said MD5. Any other ones?
Yeah, they're all MD5.
They're all MD5. Yeah. Okay, so that's a good start. So when we try to crack these passwords, we at least know the algorithm that was used to hash them. Okay, so they're all MD5 passwords. Okay, cool. We know the hashing algorithm. What do we do now? What's a good thing that we could do? One thing we could do is try to employ one of these cracking techniques. Okay, so in this case, which one of these is the most effective against this attack. So I'll let you read through them. So there's the dictionary, rule-based, masked, hybrid, or brute force, or maybe even rainbow table. In this case, let's just rule out the rainbow table, let's just say. But which one would be most effective, possibly?
Mask, probably.
Mask, okay. Which one do you think, Rahil?
I'm just thinking that
Which one do you think is most effective? I'll read over the prompt one more time because it gives us an important clue. So it says our analysts have obtained password dumps storing hacker passwords. After obtaining a few plain text passwords, it appears that they overlap with the passwords from the RockU breach. So that gives us an important hint as to which one of these attack vectors is most effective. Okay, so mask was one option. Rahil, which one do you
what
think?
if we run this hashes against the rocky.txt file?
Oh, okay. So that requires knowing about the rocku.txt. So, yes, in this case, I'll go ahead and spoil it. The dictionary attack is one of the more effective attacks. Why? Because we get an important clue here. So this RockU breach. Okay, so RockU is a company that is no longer existent, I believe. But basically, they were a company that developed Facebook and MySpace extensions and plugins. Okay, so what happened is some hacker hacked them, and he got all of the most common passwords. Okay, so that resource is actually available widely online. So I can look up the RockU password list. And generally speaking, they're usually going to be in archives or like zipped, for example. So you could see here rocku.txt.gz. So this is what's called archived, which basically just means that it's kind of like a zip. If you ever used a zip in Windows where you just compress it, just because of how big this file is, they needed to compress it to be able to send it over. So yeah, so you can see here the size is 133 megabytes, but compressed it's 50 megabytes. And it looks like in here there's 14 million different types of passwords. Pretty cool. Okay, so what we could do is we could go ahead and download this, unzip it, right, uncompress it, and then we can run a dictionary attack against it. Okay. Now, for this, we would need something like Kali Linux. So for the rest of the exercise, I'm just going to go ahead and pull up a Kali Linux virtual machine here, just to kind of show you what that process kind of looks like. So let me spin it up really quickly. Shouldn't take too long, hopefully. Just give me a couple minutes and I'll come back really quickly. Okay. Oops. Let me see. Am I back? Okay. I completely forgot that my virtual machine uses my my Wi-Fi adapter. So yeah, let me unset that and then we can continue on. Give me one quick second here. Let me delete this. Go into network. Apply. And then start it. And then I should still be connected to the internet, hopefully. Okay, cool, I am. Let me scroll back down. In this. Okay, so here's my let me just quickly log in. I mean, the credentials for it aren't anything special, but just in case. What was the login? Ah, yes, that's what it was. Ah, oops. Okay, there we go. Cool. Okay, so here we have Kali Linux running in a virtual machine. I have all the tools available. Now, this specific installation of Kali Linux is using a meta package called Everything. And what that basically means is I have installed every single possible tool that Kali Linux has to offer. So if I go to the meta packages here, not that it's super duper important to know it, but I just wanted to showcase this in case it was interesting. Eventually it'll finish updating. Okay. Oh. There we go. Okay, so you can see here, if I scroll down, we have Kali Linux default, and then we have this meta package called Kali Linux Everything. You could see it says every tool in Kali Linux. Now, would I recommend you do that? No, just because it takes, I think, like 80 gigabytes of space, and I'm realistically not going to be using like 90% of these tools. But it's still useful to have because you have access to not only red team tools, but also like blue team tools. What I would recommend instead is to specifically pick out the tools that you want. So if you want to hack 802.11 like Wi-Fi, if you want to hack Bluetooth, there's also VoIP if you want to hack VoIP stuff, so on and so forth. But we also have a bunch of other stuff. So not going to do a tutorial about it, but just in case you didn't know about that, you could do that. Another cool thing actually I wanted to show before I actually continue, completely unrelated to our thing. What we could do is, I don't remember the exact one. Yeah, there we go, undercover mode. So undercover mode is actually pretty cool. Let me go ahead and run it really quickly here. What that does is it transforms Kali Linux into something that kind of looks like Windows. So say you were somewhere where you didn't really want to look suspicious. There you go. Yeah. Just in case that was interesting for you guys. So yeah, undercover, super cool. And it's reversible. So yeah. Anyways, let's get back into our thing. Enough of having fun. So we went over one of the tools that we could use, and that's John the Ripper. Luckily, Kali actually organizes a lot of these tools for us. So if we look up, not collection, credential access, we could see a bunch of tools that we have available. Now, obviously, like I said, since I have the everything package, I'm going to have a little bit more options than normally you would. But in here, we have tools like for hash identification, right? So we could go ahead and plop in the hash we got to get what kind of hash it's coming from. But also we have password cracking. So we have a bunch of different tools. John, for example, John the Ripper. We have Hashcat, which we went over. We have OPH crack, and a bunch of other stuff. For this one, let's go ahead and just use John the Ripper. Okay, so when I run John the Ripper, it's going to give me this giant help. Um, and basically, it boils down to the following. So I have John, the option, and then the password files. Okay, so let's kind of go through some of the options. So in this case, what I'm going to do is I'm going to define a word list. I don't remember all these commands off the top of my head, so give me a second while I stumble through this a little bit. As you can see here, we have a lot of options for password cracking, so it's a very powerful tool, even though it's not quote-unquote the recommended one. Still very powerful tool. Let me see here. Is it here? Short word lists. Let me look it up really quickly. Just look up a command. Oopsie. Just because I don't want to stumble through this. I want to get over with it as soon as possible. Okay, in the meantime, actually, while that loads, it seems my internet is a little bit slow in here. One of the things that Kali Linux actually comes bundled with are word lists. So what I could actually do is I could actually navigate to the folder. I'm just going to open up a random folder here where those are at. Now, the Linux file system is a little bit confusing, even for me, and I daily drive Linux. So sometimes you kind of just need to know where stuff is. In this case, the passwords, I believe, are in user, share, word lists. There we go. And boom, we have a bunch of different word lists in here, one of which is rocku.txt.gz. Okay, and if I go ahead and open it up, preferably not in Vim, but I mean, it's fine, I guess. You can see here, we have just a giant list of a bunch of passwords. So I'm just going to scroll through them. Notice on the bottom right what line I'm at. So I'm at line 1000. And if you look at the scroll bar on the right, it has not moved at all. So lots and lots of different passwords to check against. And again, these are like based off of a password leak. So I can go ahead and use a tool and compare a hash against this giant list of words. Obviously, if the password is something like at the bottom, like kind of one of these, for example, it's going to be a little bit harder to discern than one of the ones at the top, but it's still faster than trying to brute force it. Okay, so when I use this, I need to reference it. Again, when you open up this word list, the plain text isn't going to be available. So what you're going to need to do is you're going to need to uncompress it. You could do it through the command line. You could do GNU unzip, or you could just navigate over to this file, open it, and then just drag and drop it out. Whatever is easiest for you. Either way, it all works the same. Let me see. Let me try something else. Sorry, can't seem to find the command here. Okay, cool. So let's hop back in here to the command line. Okay, so here's what we're going to need to do. First things first, we're actually going to need to put our hash into a file. Okay, so we can't directly pass in the hash just because this tool is meant for cracking more than one hash. So let's go ahead and just create a new file. So I'm just going to go ahead and just do nano hash.txt, let's just say. And let me go ahead and type in one of the hashes. So we have 68A96. If you install your virtual machine in a way that allows you to pass in your clipboard, so you could do copy and paste, it's going to be a lifesaver because doing this manually sucks. But I just do it for security purposes, just because I don't want, let's say, for example, for whatever reason, if this virtual machine were compromised, I don't want them to have any more access to my host machine than they already do. Okay, so I'm going to go ahead and save it. And if I go ahead and just check that it's there we go. Now we can go ahead and run the command. So first things first, we're going to need to do John. And then the word list, we're going to pass in. So -- word list equals /user /share /word lists. And I can use tab to autocomplete here. In this case, I have the txt file exported as _rocku.txt. Generally, you would just have rocku.txt without the underscore, but I just renamed the file. Okay, and then now I could go ahead and just try cracking it. So I'll do hash.txt. Okay, and it says session complete. Sounds good. Now we're going to go ahead and take a look at what it says. So John -- show hash.txt. And it says 0 passwords cracked to left. Let's see, maybe it couldn't figure out the thing, but the string. Let's try specifying the what's it called? The hashing algorithm. So I'm going to pull that back up, and we're going to do -- format raw -md5. Oops. Space. Oh, equals. Whoops. And it looks like this might have been the password, but let's just double check. John -- show hash.txt. Or maybe not. Interesting.
That's what I got too.
That's what you got as well. This might be it. Let's do the command that it says -- show -- format equals raw -95. Let's see what it gives us. Okay, yeah. So it's saying that this is a possibility. So it's not saying for certain that it's this password. That's probably what this question mark is. But yeah, it's saying that basically if the hashing algorithm is MD5, this is the password. Pretty cool. Okay, and so we can repeat this process for all the different hashing algorithms. I'm not going to, just for the sake of time. But yeah, you could do the same exact example against all of those password hashes, and you should be able to get the results. Okay, so John -- word list followed by the format. If we don't specify the format, it's just going to try all of them. And yeah, okay, cool. Let's move on. So let me go ahead and just minimize this. Okay, and then same thing here. So same principle. I'm not going to showcase it for obvious reasons, but basically it just says to go ahead and crack these hashes. For the reason of not wanting to what's it called? Take up too much time. I'm just going to go ahead and put them in the chat if you wanted to give it a try yourself. Boom, there they are. Okay, so it specifies the hashing algorithms, but you could also go ahead and try on your own inputting these hashes into a hashing algorithm and see what it gives you. Okay, see if it gives you SHA-512, 256, SHA-1, right, and so forth. So you could try doing that as well. Okay, cool. Next, our analysts have obtained password dumps storing hacker passwords. After obtaining a few plaintext passwords, it appears they are all in the format sky-hqnt followed by 4 digits. Can you crack them? Okay, so this one we'll go ahead and utilize a mask attack. Now, this is an example. Remember when I was going over the rules of the competition? This is an example of where we can't brute force, okay? So we know that the answer starts with this, followed by 4 digits. If we try to brute force it, first of all, it's probably not going to work. Second of all, it's just not allowed by the competition. So let's just not do that, okay? Cool. Okay, so let's go ahead and look up how to do a mask attack on John. I believe there's a mask option. I just don't remember exactly how to format it. Okay, so let's go ahead and pull up Callie again here. Actually, hold on, before I do that, let me paste these in the chat, just in case. Give you guys the opportunity to try them on your own really quickly, while I set this up. Come on. There we go. Okay, cool. So, so John, like I said, has a mask option. So we could go ahead and do John -- mask. And then we can define a mask. In this case, we know that the password starts with sky-hqnt. Okay. And then for all of the unknown variables, we're just going to go ahead and do the following. So question mark D, question mark D, question mark D, question mark D. So D in this case is for digits. You could look it up yourself. Let's say we were making a mask attack for lowercase letters. I believe it's just -L or something like that. I'm not sure. Or sorry, question mark L. I don't remember exactly, but yeah. So you could look it up those. In this case, I know that it's question mark D for digits. Next, I'm also going to assume that the passwords are probably MD5 just because of how similar they look like to the first problem. So I'm just going to go ahead and do format equals raw-MD5, though I could plop it into a hash identifier just to be double sure. And then I'm going to go ahead and actually open up a new terminal. And I'm going to go ahead and modify the hash.txt really quickly. And the new hash is, let's just do the first one, 71B81-6FE0B7B763D889ECC227EAB400A. Oops, A. Hopefully I typed that in correctly. I'll just double check. 71B 816 FE0B7B7 63D 89 ECC. Yeah, okay, cool. Looks good. Okay, and then now that we saved it, let's go ahead and run it against hash.txt. And looks like it was able to crack it. It's Sky. Maybe it's one of those two. I think that's probably what it's trying to say. So let's just go ahead and do show -- show or not. Did I get the format wrong? Is it dash the numbers? Oh, dash, yes. Sorry. Oops. There's a dash in between HQNT and the digits. Okay, there we go. So this is the possible password that we got, 8765. We could again double check this. And as you can see here, there we go. Sky HQNT 8765. Okay, so again, a very powerful attack, right? We could just define what the rules of the password are, right? And then just try against a more limited quantity, right? If this was the password and we try to brute force it, it would be generally speaking close to impossible to do just because of how much time it would take. Okay, and again, I have all of those hashes at the bottom if you wanted to try them. Let me actually label these just so we have an easier time later down the line. I'm going to put the prompt as well. Okay, cool. Next, Pokemon. Our analysts have obtained password dumps storing hacker passwords. After obtaining a few plain text passwords, it appears that they are based on Pokemon. So obviously, same thing. Similar attack vector. I want to give you guys the opportunity to go ahead and give this a try. Obviously, first things first, if we know that the passwords are based off of Pokemon, we should try to find a resource that has all of the Pokemon names in it. So yeah, I'll go ahead and give it, let's do 5 minutes, and then at least try one of them if you can't do all of them. But yeah, so give it a try. I went ahead and showed an example of how to run it on John the Ripper, but I'll just pull up that command one more time. Oh, actually, wait, let me first copy these into Discord before I continue. Boom, there we go. Okay, so let's do that. And let me pull up the command. Should look something like this, except you would just replace the word list with the Pokemon.txt. So let's just say, for example, I have it in downloads, load / Pokemon.txt. Let's just say. Okay. Cool. I'm gonna go ahead and try to work on this on the side here really quickly in the meantime, and then we'll reconvene, like I said, after 5 minutes. We'll do 2 more minutes.
I'm having some trouble with my virtual machine, so
Okay, all good. As long as you gave it a try.
yeah, no worries. I will practice that.
And I don't have the tools for it.
No?
I'm getting them right now.
Okay, for sure. Yeah, I forgot John the Ripper you have to download. Doesn't come pre-installed.
Well, I'm still setting up the virtual machine.
Oh, I see. Okay,
That's what
okay.
I'm doing.
Okay, okay. Oh, so when you were identifying the hash the last time you were cracking
Yeah,
it?
I did it manually through the website.
I see. Okay. Hey, that's possible.
That's why I just had the one done. I didn't do the rest. Because that one took like 5 minutes.
Yeah. Um,
I'm installing VMware, but do you think VMware or VirtualBox is better?
either one works. I personally would recommend VirtualBox, but either one is similar enough.
Why VMware or why VirtualBox over VMware?
It's just easier. VMware is more used like in commercial settings, so it's still important to know that specific tool. VirtualBox is just like basically completely free,
No.
so that's why I would recommend that
Are
one.
there paywalls in it?
With VMware, yes, there are certain paywalls. Mhm.
Oh,
Okay. Cool. So give me a second. I'm still giving this a try, just because I want to show at least one working. But I think I'm pretty much there already. I just need to. Okay. Let's try this out. Mm-mm-mm-mm. Do. Let me see. Um, John show txt. Right, that could be the problem. Let me try one more thing here. Let's try. Where is my command prompt? There it is. Oh, dash rule L. Okay, I'm gonna do cat slash. Sorry, I'm having an issue. I know what the issue is. I just don't know exactly how to solve it just yet. Grab. Case. Come on, man. might just move on, just because. Yes, and I'm trying to see if I could just. I'll try one more thing, and I'll tell you probably exactly what the issue is. Matter of fact, let me just try finding a different resource. Okay, let's do this. Lower. Nope. Lower. All right, let's try. Let's give this a shot. There we go. And then hopefully.
You guys are using the rocky.txt, right?
No. So this one is against Pokemon names. So the problem says that it appears they are based on Pokemon. So you could try that, but I don't think it'll work too well. Okay, there we go. Yeah, I see what the issue is. Okay, cool. So let me kind of go through the steps of what I did really quickly here. So the hash that I ended up getting was this one, Gold Duck. So the very first hash relates to Gold Duck. Okay, so how did I get that? Well, first and foremost, I went ahead and tried looking for a list of Pokemon. Now, this website that I ended up using is this list generator. What I originally used was this one, which is just a text file of all of like 809 Pokemon names. Okay, so not all of them by any chance, but still like a good amount. And so I just copied this, pasted this into a text editor, and saved it. Boom. Okay, problem is, let me show you. It didn't work. Okay, didn't work. Couldn't figure out why. I tried specifying the format, not specifying the format. Here I go, without saying the format. I got some possibles here, right, but nothing really concrete. So I thought, okay, well, it's not an issue with my list. I thought maybe it was an issue with my hash. So I tried typing in the hash again. Looks like it was able to ID it correctly. Everything was fine. What it turned out to be was, in fact, it was just the list was in upper and lowercase characters. So the first character is uppercase. But what it actually turned out to be is that the whole password is lowercase. So I would need to use a list that had lowercase names, but in this case, I just went ahead and did a generator. So here's this generator. I just went ahead and did % name lower. There we go. So that gives me all the names from all the Pokemon, all in lowercase. Cool. Generate it. Give it a second. Copy. Paste. And I went ahead and saved it as Pokemon.txt in my downloads folder. And that's what I told John exactly. So John, oops. That's not at all what I meant to do. Oh, man. There we go. Okay, so I'm saying, John, the word list is in downloads/Pokemon.txt, and the format of the hash is MD5. Cool. Try it. And didn't work. Why? Just worked literally a second ago. Oh, I think it's because it already cracked it. That's why. But if I scroll up here, you could see that I ran it here, and it cracked gold duck successfully. So if I go ahead and do John --show hash.txt, wait, I need to specify the format, raw MD5, boom, and it says that gold duck is the possible password. Okay, it's not for sure that the hash is MD5, so that's why it's a question mark. But if it is MD5, then boom. Okay, cool. Let's move on. That was that. I think we'll skip any other ones that are similar. Okay, so this one is a little bit more difficult. So let's not skip this one. So it says Windows. Our analysts have obtained Windows password dumps storing hacker passwords. Can you crack them? Okay, so let's go ahead and go through this. Okay, Rahel, I just saw your message. Nice, looks like you got them through. So yeah, definitely possible. Mine just took forever to do. Okay, so I went ahead and pasted those in the chat, and I'm not going to give you guys the opportunity to do them yourselves, just because we're running a little bit short on time. But here is what we need to do. Okay, so we already have the clue that these are Windows dumps. Okay, so we need to figure out how Windows stores passwords. So let's look it up. Again, I've never solved these, so I don't know the answer. I just know that they store them a little bit differently compared to everybody else. So Windows.
I guess it is the NT.
You said what?
Windows stores the password in the NT hash format. NT.
NT hash. Let me see. Okay, yeah, there we go. NTLM. Let's look up that. NTLM. NTLM is a suite of Microsoft security protocols used for authentication. Okay, cool. Sounds good. So then how do we crack that? So we could do, let's say, John the Ripper NTLM. Let's just see how we could do that. How do you crack NTLM hashes? Hello, James. Okay, so we want to extract the hash. Cool. And then we install John. Cool. And here we go. So we give it one of the hashes, we give it a word list, we tell it that it's in the NT format, and should be good to go. So let's give this a try really quickly. Bear with me, it might be a little bit of typing because I need to do it manually. Okay. So let's put this this in here. Let me just open it in the text editor just because it's a little bit easier to do. Oops. Open. Download. Or it's in home actually. Okay. So 21259DD63B 980471 AAD3 B435 B51404 E1 E43E7 B8188 B5ED B I think that's a it's a 0. Nice. Okay, thank you. 066 EB 58 CCDC 1823. Okay. Cool. Let's give it a shot. So we're gonna bring back the RockU list. Scroll up past all these. There we go. Cool. And then we're gonna do format NL. And let's see. Did I not do that correctly? Was it not format NL? Was it a different one? It was. No, it was. Oh, NT. 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 Okay, there we go. Cool. So we got one of the passwords is star fox with the 0. Cool. I don't think I need to really demonstrate this anymore. Yeah. What I'm thinking I'm going to do for our next meeting, if I need to use Kali, I'm probably just going to SSH into Kali Linux just so I could do the copy pasting stuff instead of typing it out. Just for right now, I'm not gonna do all that, even though it's probably better. Okay, cool. So we get that idea. Definitely possible. Okay, next. Our analysts have obtained password dumps storing hacker password. It appears that they are based off of Law and Order SVU episodes and end in 2 digits. I wonder what we're going to need to do. Okay, let's not actually crack the passwords if you want to. I'll actually just put them in the Discord if you want to. But let's just kind of go through the process of how you would do that in theory. Okay, so I'm going to put them in there. Boom. Okay, and so we'll look up Law and Order SVU episodes, and we have Wikipedia, and would you look at that? We have this list. I'm wondering if we can extract this somehow. Let me see. Maybe it's at the bottom. I can just do this. Let's see, external links. Sure there's a way, I just don't know how to. Let me see. Yeah, that's what I thought. Okay, let's try a different resource, maybe. List. I saw GitHub on there. That would be useful. Oh, I see. So it gets the episodes from Wikipedia page and puts it into a TXT file. Okay, so yeah, it looks like in this case we would need to. Here's the video for it. Okay. Anyways, hopefully you guys can see the point. You basically could just use that tool that somebody has. You probably want to double check to make sure that it's not malicious. But yeah, you'd want to basically somehow extract these episode names right here, Payback, A Single Life, whatever, put them into a TXT file, and then just add a mask. So it's just, it's going to be rule-based. So you give it a dictionary, and then you just add 2 digits to the end of it. Okay, should be pretty simple, something that you could probably figure out, at least with the help of AI, how to do and that kind of thing. Okay, cool. Let's move on. Next, PDF. We have captured an encrypted PDF from a hacker's FTP server. Decrypt it and find out what you can. Okay, so I'm going to go ahead and put this in the Discord. There we go. And if you follow the link, it will... Let me see. So on my browser, because I have a PDF viewer in the browser, it's asking me for a password to open this PDF. What I'm going to do is I'm going to actually go ahead and download this. But I'm going to download it on my VM. So give me a second while I type in the URL here. So this one I definitely do want to showcase because this is another use case of John the Ripper here. So let me open up Firefox here, and we're going to do assets.super. Actually, I could probably just look up the name of the exercise. Let me see. Trove. Yeah, there it is. Cool. I don't have to do it. All right. Boom. And I'm going to download it. I just realized this is not in my VM. I'm so stupid. Okay, NCL Tro PDF. Big oopsie there. In here. No, it's not in here. If I just look it up. PDF. Yes. That's exactly what I want, actually. Actually, no. That is not what I want. PDF. What's the other one? Yeah, there we go. Okay, encrypted.pdf. Go ahead and cancel. Download. Just put in my downloads folder here. Okay, cool. So, yeah, let's go ahead and give cracking this a try. I believe if you just input the PDF file into John, it should be able to do it. But let's see if that's possible. So, I might be wrong. John, let's just use that. And then can we feed it and slash downloads slash encrypted. Oh man. Oh, okay, so we're all the way at not the right place. There you go. Download slash encrypted. Let's see. Okay, let's give it a try. Meantime, there might be another tool. Let me see if I can find a PDF parser. What does this do? PDF parses program used to parse a PDF. Doesn't look too useful. Okay, let me see. Yes, so you can see it's going to take a while here.
Is it running right
It's a great question. I think so, yeah. If I press Q. Oh, right when I press Q. I don't think it's probably going to show me anything too useful, but let's just see. John, dash show. Downloads. Encrypted. Okay. I see. Yeah, it's probably interpreting the binary data in the PDF as something. So let's not do that. Let's see if we can convert. Let's see. Convert PDF for John. For John the Ripper, I should say, maybe. Okay, let's John the Ripper PDF. Don't see anything with.
From what I see, there's a tool called PDF to John,
Oh, let's look that up. PDF to John.
which you should already have in the Linux.
Do I? No. Let me try. Just running it. PDF to John. Oh, nice. Okay, that's cool. I didn't know that. Okay, cool. So let's do PDF to John. And then we're going to go ahead and do download / encrypted. And then let's go ahead and output it to a file, I don't know, pdf.txt. Cool. And then we're going to do John. Let's just get this back here. And then we're going to do pdf.txt. Okay. Again, let's give it a second here. Let's just take a look at what that looks like. pdf.txt. Okay, for sure. It looks like it kind of formats it. Oh yeah, in like a Unix style. So the username, quote unquote, is where the file is, and then the password is all that. So you can see that it's in a PDF format. Okay, so we'll just give it a bit more time. Let me try just increasing it really quickly. Let's just do -- fork equals 4, maybe? I don't know. Okay, got about like 5 minutes left, and then we'll wrap it up. Okay, in the meantime, while this runs, hopefully it finds something. Let's continue on. But yeah, I guess that's basically the idea. So yeah, the question asks, what is the password used to encrypt the PDF, and what is the flag? So yeah, I think once you decrypt the PDF, the password is going to be in the PDF file. Okay, cool. Next, we have obtained /etc/shadow from a Kali Linux machine. Help us obtain the password. We think this might be a password from the RockU word list. Okay, for sure. So a couple of the questions. Let's start with the first one. What is the username of the only user account with a password? I think it's going to be relatively simple to see which one it is. It's going to be this one, Holly, at the bottom, just because it has all of this going on. The rest of them, I believe, are just like settings maybe or something. Maybe gives file permissions and whatnot and like user ID. So yeah, Holly looks like would be the answer for the first one. And then on what date was the user's password last changed? That's interesting. Okay. So let's see. See last password change /etc/shadow. How do we check that? I wonder. Okay. It looks like. Is it this maybe? No. It looks like it was never changed, because from what I'm seeing on a resource online, it looks like there would be a timestamp here that kind of looks like 1969-10-02, kind of like that. And so the last password change was October 2nd, 1969. But looks, well, maybe that's not the user with the password, but if it is, then yeah, because none of them have that either. So yeah, looks like it's probably undeterminable. Not sure. Okay. And then what is the salt used to secure the user's password? Very interesting. Not sure how you would determine that. What is the hash digest of the user's password? Looks like it's this whole thing right here, I'm guessing. And then what is the plain text password? Okay, so let's see how we could do that. Well, let's go ahead and give this a try. Let's see. How to determine password salt /etc/shadow. Let's see if we can figure this last one out here. Okay, so it looks like, according to this person on Stack Overflow, I just saw it. User picks encrypted. Let's see. I just saw it somewhere. I think the salt might be here from what I'm seeing. It's like the dollar signs. But let me see. This one, like I was saying in the previous meeting, the questions get harder as they go down. So this is the last question in the password cracking category. So it's obviously going to be the most difficult. So obviously for this one, you're going to need to have some knowledge on Linux and how it stores passwords and stuff like that, which I don't have. But let me really quickly just send this. Oopsie. Let me send this in the chat here. Hello. There we go. Oh, and it's too long. Great. I love that. If I delete these, nice, and then a separate message. There we go. Okay, just in case you wanted to give it a try. But it looks like this resource is good for telling us what's going on. So we have the user followed by the password. Okay, so this password is where the stars are. So all of these don't have a password, except looks like MySQL has a password. It's exclamation point. Nice. DBNXM. Or maybe exclamation point means something else. Yep, so none of these, until we get to the bottom, which is Holly. So right after the first colon is this big super thing right here. Okay. And then as for last changed, it's going to be directly after the password in the next colon. So this right here looks like it is formatted in the number of days since January 1st, 1970. So if we just go 18,934 days after January 1st, 1970, I'm sure there's a tool that lets you look it up. You can figure out when this was last changed. Stuff like that. Cool. And later down in the article, it breaks it down. So the user John has a password hash starting with blah, blah, blah. Expires after da, da, da. Okay. Generating encrypted passwords. Some common algorithms include MD5 with the prefix 1, Blowfish with the prefix 2, SHA-512 with the prefix 6. Modern systems use salted passwords with random data. This protects against pre-computed blah, blah, blah. Okay. So this gives us a little bit more information. But it looks like, let me see. /etc/shadow salt y. Oops. Y salt /etc/shadow. Let's take a look here. Is that? Let me see. I keep seeing this command chag show up, so maybe that's something that we could run. Okay. Well, I'm gonna forgot that this was running and I stopped it. Let me just rerun that again. Maybe it'll come back with something eventually. I'm not gonna put money on it. Use case for why you should have a strong laptop, though. Mine is not. Okay. Boom. Okay, so see age. Let me see. Okay, cool. And then, so that just gives me the date of mine, which is not entirely useful. Okay, we could try that. Okay, so let's see. I'm following this resource, just in case you want to follow along. Looks like we can feed in a thing here. Yes. Okay, so it says that the $y$ or $7 is yes crypt. Okay, so we know what kind of algorithm it's using. As far as the salt, let's take a look back at it. So following that resource I just linked, so Y is the format. The parameter is this, J9T. And then the password, or sorry, the salt, should have been, this right here. Yeah, so this right here, in between the $, that's the salt right there. And then all the way from the 1. So that's the salt. Cool. And then after that $, is the actual encrypted password. So this is the hash digest. Okay, sounds good. So let's see if we can ask our good friend, Mr. Grok, because ChatGPT doesn't want to help us with doing cybersecurity stuff. Let's see. Given that a password in /c/shadow is using yes crypt as the parameters J9T, given a salt and password, how can I crack it? Then I'm just gonna supply it with the thing. Mr. Grok, thank you for your service. W's in the chat for Grok, please. It's honestly like super annoying when you tell like ChatGPT like I have permission to do this, like X, Y, and Z. It's like, you know, it's not, and it's like never anything super crazy. It's like always something super simple, and it's like, no, I'm not gonna let you do that. Like, fuck you, dude.
You're good at that.
Yeah, exactly. Okay. So, right, we need John. Create a phone. Okay, so we need to obviously put this into a file. So let me pull up good old Kali Linux here. This is going to be the last thing, and then I'll wrap up. I know I'm a little bit over time. Hopefully you guys can forgive me for that. Okay, so we're going to do Holly. Let me pull up on my second number here. Colon, $, $Y, $J, 90, $, oops, other way, WZIXHASN 8SDXHCQU YZH 01 $KZLIO 78 LILITOBSX 17 ECFF 1E 2 SBSDUH P1S Z E W U lowercase H R L4. Okay, cool. And now we just need to save it. Cool. We come back to John here. I'm going to open up the... okay, let's just assume this is never going to finish. Okay, it's probably realistically never going to finish. Okay, cool. So, let's go ahead and do John -- word list, all that good stuff, and then we're going to find it in hash.txt. So hash.txt. And let's give it a try. No password hash is loaded. Interesting. Are you sure about that? Let me try. Cat hash .txt. No, it's definitely there. Just kind of being a pain in the A. It says, let me see. Let's see what Mr. Grok says. Maybe we just need to define the format is all. -- format. Let's try yes crypt, because that's what it was called. Oops. Need the equal sign. Okay, unknown. Great. I love that. Let me try looking it up. John the Ripper. Yes, crypt. If anything, I could probably just get rid of the Holly colon whatever thing. Okay, let's find this other thing. Let's see if it's valid. Okay, crypt. Maybe that's what it's supposed to be. Format equals crypt. Okay. Warning. Will not load such hashes. Okay, thanks for being a loser. Not looking too good. Let me try just one time, just in case I'm going crazy. Okay, let's try seeing somewhere else. Okay. Format crypt. Okay. So notice no hash in there. Okay, so it says something called unshadow. Is that a command? Yes, it is. Cool. So here, let me put the reference that I just found. There we go. Okay, unshadow hash.txt. That's not the full command. The password file and the shadow file. What is the shadow file? You'll see something like this. It says Now the next thing we need to do is copy these two. Oh, I see. Okay, so we have. It's not too useful. Okay, never mind. Okay, so this would only apply for if we had the regular password list, which we don't in this case. We only have the shadow. Let's try seeing if there's another tool here. Just in case I'm going crazy. No, this is just the shadow. Okay. Okay. Let's see if I do John -- format crypt word list. Yeah, okay, so it looks like it needs to be unshadowed, but we don't have that. What is it? Kali Linux unshadowed. Let's look at the tool. Honestly doesn't help too much. Okay, interesting. Okay, let me try getting rid of this thing in the front. Maybe, just maybe that could possibly. No, let's try without the format. Yeah, okay, so, let's see, John, ID, $y, unsupported. Let's see if we needed maybe to install some sort of module. John hashes. John formats. Let's see here. No, nothing here. The hash was missing a bit. It works in John now, but it's very slow. Are there any online? Ooh, is that why maybe it's missing a bit somewhere? Let me see. Maybe I typed it in wrong. It's very possible. Very, very possible. Okay. So, $y, $J9T, // WZIX HA SN8S DXHC QUYZH 01 $. Cool. Next, KZ LIO 78 LIL TOBSX. And another / 17 EC FF 1E 2 SB SDUH P1 SZEW UHRL4. No, looks correct. Okay, I'm gonna try like one more website, and then if it doesn't show up on there, I think I'm just doing something wrong. Definitely just me doing something wrong. Okay, let's try. I'm just gonna try like on here. Yes, crypt. Decrypt online. No. Okay. I guess we'll just have to leave it up in the air. But generally that's how it should be done from what I see. You just give it a word list, you tell it format crypt, and then that's pretty much it. There aren't really any other things to it. The only other thing I can see that could possibly be an issue is I don't have the password list. I only have the shadow, so like you have to apparently use like the unshadow tool that I briefly looked over to be able to unshadow it. But for looking at the output from the shadow file, it didn't really look all that crazy, so I honestly don't really know what can be done here. It could just be something that I'm not doing with John. Yeah, obviously it says type ID appears to be unsupported on this system. I'm not sure, but I saw another post on Reddit that had that same error, or like a similar error, and they just said that they were missing a bit, so that's why I thought maybe like just doing something wrong, but I'm not sure. Anyways, if you guys want to give it a shot, it's there in the Discord. If you end up cracking it, please let me know. I'm like super interested to see if you did something different, or if it's just a me issue. Okay, but that wraps it up pretty much for password cracking. So the only thing now, I'm going to have some self-directed study here that I'm going to put in the chat. So this is going to be for password cracking. Okay, so I'm going to attach these exercises in the chat. Yeah, so next time we meet, what we're going to go over, if I go up to the schedule really quickly, Okay, so because we are missing a day, what we're going to do next time is we're going to go over scanning and log analysis. So I think log analysis we can probably knock out very quickly. So we're going to, but we're going to do scanning first because that's one of the more simpler topics. Okay, cool. So Saturday, scanning, log analysis. Any questions on what we covered today at all? I know it's kind of a lot, but generally speaking, it's the same couple tools, right? As long as you understand the concepts, right? What a salt is, hashing, all that kind of stuff, you can kind of figure it out. Obviously, I only use John in my examples, but there's plenty of other tools that you could use for password cracking. And some of the resources that I have outlined here, as you can see here, I have some Hashcat exercises. It's like a different website where you can download and practice using Hashcat. Okay, cool. Okay, anyways, we're all set to go. I will see you guys on Saturday. Other than that, have a great rest of your days. Bye-bye.